Hello and greetings to our beloved lecturers Ahmad Shahir bin Abdul Aziz and to my fellow friends. My name is Andre Antonius and my partner during industrial training is Zulkhairi bin Yaakub. From 14th of August until 29th of September, we are doing our industrial training at Sabah Rubber Industry Board, and we are choosing the rubber nursery department which was located at Sungai Damit, Tuaran, Sabah, as our focus to learn about how rubber is cultivated during the process. Before we wrap up, I want to express our heartfelt gratitude to Sir Ahmad Shahir, UITM, and Sabah Rubber Industry Board. They played a vital role in making this industrial training program possible. First and foremost, a big thank you to all the dedicated participants. Your enthusiasm and commitment are the driving forces behind the success of our training. Special appreciation to Mr. Zulkifli and our instructors. Your tireless sharing of knowledge has made a significant impact on our participants. To our mentors, thank you for generously offering guidance and support. Your mentorship is invaluable in shaping the professional development of those under your guidance. Our sincere appreciation to Sabah Rubber Industry Board for enhancing the quality of our program through collaboration and support. Acknowledgement also goes to our stakeholders. Your support is fundamental to the success of this program, and your belief in continuous learning is commendable. On behalf of UITM, my deepest gratitude to everyone involved. Your collective contributions have made this program a success, and we look forward to a continuous collaboration. Thank you all for your dedication, support, and collaborative spirit. Let us continue to learn, grow, and make a positive impact in the rubber industry. Have a wonderful day, and we eagerly anticipate future endeavors together. Sabah Rubber Fund Board (SRFB) is an agency of the state government under Ministry of Agriculture and Food Industry in Sabah, and was established through the enactment of the Rubber Fund Board 1950, which was later amended to the Rubber Industry Board enactment on year 2013. The purpose of this establishment is to fill job vacancies by residents local in venturing into the field of rubber industry to improve standards of the lives of the locals, especially for Bumiputras. The Sabah Rubber Fund Board opened new land to expand rubber plants and encourage smallholders to replant the breed higher quality rubber according to the modern cultivation methods. Nowadays, the Sabah Rubber Industry Board SRIB is a statutory body of the state of Sabah under the Ministry of Agriculture and Food Industry that handles all rubber industry activities in the state of Sabah. SRIB was established in 1950, which was formerly known as the Sabah Rubber Fund Board (SRFB). The Smallholder Development Division Supply Unit oversees nurseries providing plant materials to smallholders. These nurseries, located in Tuaran and Papar, aim to meet small farmers' needs and ensure high-quality rubber seedlings. In 1991, 900,000 rubber seeds and 300 grafts were distributed for planting, generating over 50,000 ringgit Malaysia in sales. In 1992, 700,000 young grafts and polybag seeds were produced for clustering and placement scheme. Group smallholders benefiting from better management achieve higher rubber prices, emphasizing the importance of effective management in improving yields and income. The vision of Sabah Rubber Industry Board is a modern, viable, and dynamic rubber industry, while their mission is to develop the rubber industry in an integrated manner through efficient management of the smallholder sector, increasing commercial production, and diversifying downstream industries capable of competing at the global level. So, this is our training schedule during industrial training at Sabah Rubber Industry Board. Rubber was brought to Singapore in 1877 by the British from Brazil, Kew Gardens in London, and Sri Lanka. Southeast Asian farmers started planting rubber trees in the 1880s due to its demand. Malaysia, with its ideal climate and abundant land, became a major producer after the 1890s alongside tin. By the 1930s, Malaysia supplied half of the world's rubber. Chinese and Indian communities in Malaysia traced their roots to laborers on European-owned rubber plantation, transforming Malaysia into Britain's richest colony. During post-independence, many plantations shifted to Malaysian ownership or converted to palm oil. Falling rubber prices led to abandoned farms with 300,000 hectares left idle between 1999 and 2004, and some of them replaced by more profitable oil palms. Malaysia, once a major rubber exporter, now imports rubber. Traditionally, half of Malaysia's rubber came from smallholders. In the 1990s, a rubber tapper working 6 hours a day, tapping 400 trees around $131 monthly. Government support of $65 was given if monthly income fell below $60. Declining rubber cultivation has led to a shift to more lucrative crops, making Malaysia one of the world's largest rubber importers. Based on Sabah Rubber Industry Board suggestions, they were using 6 types of clones in the cultivation, and they were PV260, PV350, PB347, RRIM 2001, RRIM 2002, and RRIM 2023. The seeds are oval-shaped, weighing around 3.5 to 6 grams, with a tough and glossy brown or grey-brown coat featuring darker specks. The embryo inside has a radicle pointing to the micropyle and is surrounded by 2 white cotyledons against the endosperm. About half of the seed weight is endosperm. After dispersal, the seeds quickly lose viability. The plumule helps with photosynthesis. The radicle absorbs water and nutrients for photosynthesis. The testa protects the embryo, and the cotyledons provide nutrition for the plant embryo to germinate and grow. The rubber tree possesses a combination of creeping and taproots in its root system. Approximately 15% of the rubber tree's overall biomass consists of secondary and tertiary roots, which are extensively spread and accompanied by a well-developed taproot, as indicated by Heng et al. In 2017. Simultaneously, additional lateral roots emerge from the main taproot just below the initial ring of laterals. These lateral roots exhibit rapid growth and are densely covered with root hairs near their tips, as highlighted by Gomez in 1982. The leaves of Hevea brasiliensis are trifoliate, measuring between 10 to 15 cm in length and 3 to 6 cm in width. The plant bears monoecious flowers arranged in panicles with female flowers at the apex and male flowers on the lateral branches, as outlined by the Fidipedia in 2009. Hevea brasiliensis is characterized as a monoecious plant with a declinous flowers clustered in panicles resembling pyramids. These inflorescences, short and pubescent, feature numerous branches supporting flowers of both sexes. The rubber tree initiates fruit production at the age of 4. Each fruit, with 3 or 4 seeds, splits and ripens, causing them to fall to the ground. Every tree yields around 800 seeds, totaling approximately 1.3 kg biannually. The seed comprises 2 parts, a thin hard shell and a kernel containing oil, widely used across various industries. Simultaneous extraction of the kernel and shell results in a decorticated oil cake or meal with a high fiber content. In Malaysia, rubber trees are commonly found with a typical height of up to 25 meters in plantations and up to 40 meters in the wild. The latex, usually white or yellow, is predominantly located outside the phloem in latex vessels within the bark. These latex tubes forming a right-handed helix at an angle of approximately 30 degrees horizontally, can extend up to 45 feet or 14 meters along the tree. In plantation settings, trees are often smaller due to two primary reasons. Firstly, their growth is slowed when tapped for latex, and second, they are usually felled after around 30 years as latex production declines with age, rendering the trees commercially unviable. The rubber tree thrives in tropical or subtropical climates without frost and requires a minimum annual rainfall of 1,200 mm. Frost can have detrimental effects on production, causing the refined rubber to become brittle and breakable. A single frost event has the potential to impact the entire rubber plantation negatively. In the nursery, we use wild soil with clay silt for optimal plant growth. The polybags, measuring 7 inches in width and 15 inches in height, were equipped with UV protection to shield them from direct sunlight. Materials such as scoop, polybags, wheelbarrow, cutter, metal wire, and wooden stake were employed. The wooden stake marked the initial 40 polybags in a row, ensuring straight alignment using a metal wire. When filling the polybags, we stomp on them to fit the soil snugly and maximize capacity. Gaps were filled with an additional soil. A polyethylene sheet was placed under the rows for added protection. At SRIB, polybag rows were either 50 meters or 25 meters long, creating an ideal environment for successful plant development in the nursery. The planting bed measures 4 feet in width, 82 feet in length, and 1 feet in height, capable of sowing 200 until 250 kg of rubber seeds. Constructed with brick walls, it is filled with friable, clay-sealed soil, like the polybag requirements. Before sowing, the planting beds are cleaned to remove old or damaged seeds, preventing pests or diseases during planting. Rubber seeds are arranged without overlapping on the beds for optimal germination. After sowing, beds are covered with 4 to 6 inches of sawdust from brown timber, avoiding rubber tree sawdust to prevent disease spread. In the absence of sawdust, river soil or normal soil is recommended. Hypogel germination typically occurs a week after seeding. The radicle penetrates the testa, forming the lateral roots. The main taproots develops and the plumule emerge, growing vigorously. After germination, the first leaves appear in about 8 days. This process ensures successful seed germinations and early plant growth. Transplanting rubber seedlings involves moving them from planting beds to polybags using wooden stakes. This is done 14 to 21 days after germination. The stem grows in intervals with rapid elongation followed by a rest period. Leaves develop in tiers. Healthy seedlings over 4 inches tall are selected for transplanting. Using a wooden stake, a hole is made in the middle of the polybag with 4 to 5 inches deep to transplant the seedlings. Carefully remove attached to soil to avoid seed detachment, preventing transplant shock, which can harm the root system and lead to a loss of nutritional support. Following these steps ensures a successful and healthy transplanting process.
Assalamualaikum and greetings to Sir Shahir. My name is Zulkhairi bin Yaakub, and together with Andre, we completed our practical training at USG Sungai Damit. Okay, we will go on to the next nursery management step, which is fertilizer application. At USG Sungai Damit, they undertake 2 stages of fertilizer application, which is stage 1 after transplanting and stage 2 after successfully budding. For the initial stage, they employ 2 types of fertilizer, which is Agroblend and Cockay fertilizer. Agroblend is a slow-release fertilizer with an NPK ratio of 17, 8, 9, and 3 and weight around 25 kg per bag. Cocoa fertilizer is a granular fertilizer with an NPK ratio of 7, 7, 7, and 1 plus TE and a weight of 20 kg per bag. Agroblend fertilizer can be used 1 week after transplanting, whereas cocoa can be used 2 or 3 weeks after transplanting. Each application of agroblend requires 8 to 10 grams per seedlings, so if done correctly, 1 bag of agroblend can cover around 2,500 seedlings. The cocoa application is 1 nugget per seedling and each nugget weighs around 10 grams. Therefore, 1 bag of cocoa fertilizer can cover up to 2,000 seedlings. Next, budding rootstock is the primary operation at USG Sungai Damit Tuaran, and it pays the highest wage rate of any job in the nursery due to the high level of competence and consistency required. Every nursery worker must undergo a budding course to learn and master the budding skills before requesting the job with the nursery. The equipments required for the job include pruning shears and budding knife and also budding strips. Basically, the steps to budding are: firstly, select the clone, and the clone must be the pure and recommended by the Malaysian Rubber Board. The age of the rootstock must be 2 months old, while the trunk must be as big as pencil or larger. And then, cut a parallel vertical line on rootstock above the poly bag and peel the tree bark. After that, do the same thing on the bud wood. Then peel the buds. Make sure the eye buds still intact, and then lastly, insert the bud's eye into the grafting on the rootstock. Finally, wraps it using the budding strips. Check the budding after 21 days. The graft buds will be looking green if the grafting is successful, and then the budding strips can be opened at that time. But if the budding failed, do the same process on the side of it. We move on to the pruning. Pruning is done after the budding is successful. It must be done on 2 whorls of the seedlings, but in the case where the seedlings are healthy and the trunks are thick, you can do the pruning below 1 whorl. Next, after you have pruned the seedlings, you must do the nicking, and you have to nick all the remaining bud eye that are available on the trunks to avoid any branches from growing and taking the nutrients from the budding. We were given the opportunity to go to the LAGS training center to learn about rubber tapping and making the rubber sheets. Mr. Andy and Mr. Sanzu are the one in charge during our visits. The first activity that we learned is rubber tapping. The tools needed to perform the tapping is tapping panel, tapping knife, and tapping ball, and also screwdriver or any other sharp tools. Firstly, measure the girth of the tree to identify the diameter of the rubber tree. And then, use the tapping panel to measure and mark the line for the tapping. Lastly, begin the tapping from above left to below right, with the angle should be 30 degrees angle. The height should be at least 5 feet. The second activity that we learned at the training center is making the rubber sheets. The materials that needed is latex, 15 ml of 98% acid formic, and then 280 ml can of water, 5 liter of tray, rubber press machine, rubber sheet machine, and then roller. For the procedure, firstly, mix 15 ml of acid formic with the can of water, and then pour the latex into the 5 liter tray and mix the solution with latex. Remove the air bubble from the mixture, then wait 10 to 15 minutes till the mixture becomes spongy. Once it's ready, roll the mixture until the size of the mixture are suitable for the rubber press machine. It is about 5 cm thickness. After the mixture becomes sheet-like, use the rubber sheet machine to make a pattern. This is to facilitate and speed up the drying process. And then, wash the rubber sheet from any debris and dry it for 5 to 7 days. For the recommendation, we noticed that the nursery faced a problem of labor shortage to cover all the activities in the nursery, especially for the maintenance work. Thus, USG Sungai Damit must recruit a suitable workers to solve the problem. The second one is upgrading of the internal road infrastructure within the nursery. The current state of the roads is observed to be lacking, presenting a challenge that needs immediate attention. The USG Sungai Damit Tuaran Nursery should prioritize the enhancement of its internal roads to minimize vehicle damage and improve overall accessibility. In conclusion, the practical training at the USG Sungai Damit Tuaran Nursery was a beneficial and engaging experience that provided us with the skills and information required to contribute effectively to the field of nursery management in our future employment. That is all from both of us. Thank you very much.